so if I have the derivative of e to the 3x, I say it's e to the 3x, and then I have to multiply by the derivative of the exponent. So I would have to multiply by 3 because x to the first is a linear term, so we use the coefficient. Now, remember with integrals, we are working backwards. So if we multiply with derivatives, that means we have to divide with integrals because we're working backwards. So the derivative or the integral of e to the 3x dx is going to be e to the 3x over 3 plus c. All right, so let's look at another example. Let's say that we have something like 16 over x, 1 to e dx. So in this case, we have a definite integral, and so as a definite integral, we need to first use our integral rules and then plug in the upper bound minus the lower bound. Now, this particular integrand is kind of incognito because the thing is when you would try to take the derivative, you would move up the negative or the x to the first as x to the negative 1, and then I would say, okay, I'm going to add 1 to the exponent and divide by the new exponent. But as soon as I go dividing by that new exponent, I see I'm dividing by 0 in the denominator, and I can never have a 0 in the denominator. That is undefined. So that is what tells us when we get this 0 in the denominator that something is afoot and we need to think differently about what our integral rule is going to be. So this is not going to be a power rule question because what happens is if I take the derivative of the natural log of x, that gives us 1 over x. So when I work backwards, if I integrate 1 over x, that is going to give us the natural log of x. So to see this 1 over x, we first have to take our constant of 16, and you can either move it in front of the integral sign, or you can rewrite this as 16 times 1 over x. But you need to recognize that the 16 is a coefficient, and then really what we're trying to integrate is 1 over x. And the integral of 1 over x is just going to be the natural log of x. The 16 constant coefficient is going to tag along. Now, we're not going to add plus c on this one because we have bounds. We have 1 and e as bounds, so we need to draw our bracket and have 1 and e. So now what we do is we plug in the upper bound first minus the lower bound plugged in. All right, so my upper bound is e, so I have 16 natural log of e minus, and then the lower bound plugged in, natural log of 1. Now this you can actually do without a calculator because remember how we said the natural log has base e, this has base e if we assume that, again, the exponent is 1. So that means the natural log and e will cancel and we will just have 16 times 1 or 16 minus, and then the natural log of 1 is equal to 0. So this is going to become 0. So we'll have 16 minus 0 formally, and then our final answer will be equal to 16. But this whole thing about how when you get 0 in the denominator for the power rule, that is your big red flag that it's not going to be a power rule question. It's actually that you're looking at the natural log of x. So I always kind of think if I get a 0 in the denominator, it's this natural log of x that I really want as my answer. Okay?